So this week we are back to one of the topics that we discussed in week 1, which was thematic maps, but we're going to actually use data to create different types of thematic maps. And so there's basically two different kinds, quantitative maps and qualitative maps. So if you remember in the first week we looked at reference maps, that idea that reference maps are focused on location. There's no major emphasis given to one aspect of another, but thematic maps are based on the distribution of geographic data. So you could look at a map of rainfall in the U.S. and make an understanding or determination of where you get more rainfall over one place, whereas the temperature is higher. Look at elevation change, different kinds of vegetation. Or you can look at population density. The census data is all about looking at different population variables, gender differences, age differences, economic differences. Look at crime data. So all of these different kinds of information can be used to create thematic maps where you're trying to understand how that variable or how that geographic phenomena changes from one place to the other, is represented in one place or another. So qualitative data is a term that's used to look at types of information or categories of information, and the focus is where are the elementary schools and the middle schools and the high schools, what type of school, instead of just saying this is a school. Looking at different road surfaces or different road usage. So what kind of road is that? Quantitative data is looking at the magnitude of the information, or how much or how different it is. So you could map elementary schools and have them symbolized by the number of students. So elementary schools with few students could be a small triangle, and elementary schools with a lot of students would be a larger triangle. And that gives you more information, not just that it's an elementary school, but that it has some kind of quantitative difference. So when we look at the attribute table in ArcGIS of volcanoes in Oregon, you see there is a field. It's a name field called nominal data that shows what is the name of that volcanic event or that record, and what type of volcanic feature is it. It's a volcanic field, and how many known eruptions have there been in that field, and here there are none. So we have data that could be used to make a quantitative map or showing categories. Quantitative map or showing the number of eruptions, or qualitative map, which is showing the categories. So in the bottom, I have taken each of these fields and assigned it a color, a separate color, so that calderas are blue and cinder cones are green. And you can see that while there are unique names for each of the volcanoes, there are many different volcanoes that fit into the volcanic field category. And so here I have stratovolcanoes are red, and I can see 1, 2, 3, 4 different stratovolcanoes on my map. The quantities are shown by magnitude, so the circle gets larger as the known eruptions get larger, and the standard gray is used for unknown. So I have an unknown event here, and then 1 to 2 is a light tan, 3 to 5 is pink, and then 11 or 6 to 11 is the magnitude of the highest known eruptions. And you'll notice that the -999 there is a common variable to put in place of an unknown data. One thing that can be used to describe data is also how it moves across the landscape. So whether it's continuous data or discrete data. So generally, continuous data is present no matter where you are across the landscape. And so temperature, every place has a temperature, every place has an air pressure, every place has an elevation. So I'm not, the change between that data is continuous. It never, the variable or the amount will change, but the existence of it doesn't change. Discrete data does not continue. So I can either be in a house or out of a house, or in the river or out of the river. So this data has kind of an end to it. It's not considered continuous data. So on a map, you might see that elevation or slope would be the idea of continuous data. So here we've got orange for moderate slope and red for high slope. And green is low slope, so that continues throughout. But then you have these little dots on the map that show discontinuous data. So it's kind of the, well, here's the continuous one here, and then I've added the dots to show residence would be discontinuous, or even discrete data would be kind of the roads, things like that you would see on the map. So remember that in order to map the data, we have to have absolute location associated with that data. So if I wanted to map the location of different trees, so let's say I'm looking at tree canopy, I need a point to locate that tree. I could use a polygon then to identify a city block, or lines, polylines to identify rivers. And each of those, the point, the polygon, and the line, are identified with assemblages of latitude and longitude points, so that I could have 1 XY for a tree and at least 4 XY to close in that polygon for a city block. I would have to have 5 to close in a square polygon. And then the line segment, so one segment of a river would have 2 XY, the beginning of that line segment and the end of that line segment. Another absolute location would be an address, and I could use that address to go through a process called geocoding, which would take that address and put it on a map using road data and sometimes XY data to accomplish that. Associated with your absolute location then is attribute information. So the type of a tree, the height of the tree, the width of the canopy, the number of people in a block. So the type of a tree would be categorical or qualitative information. The width of the diameter of the tree canopy would be quantitative information. So you can have the stream, whether it's a river or a tributary, would be the type of stream. So again, that would be qualitative or categorical data. And then the discharge at any segment of the stream would indicate quantitative data. So when we're looking at thematic maps, you can also map things with just showing one single variable, or you can do multiple variables or have a multivariate map. And so in the qualitative lab that we're going to do, you will notice that we're going to map polygons, and then we're also going to map points to add information. So we have 2 variables being mapped on our final project. Quantitative as well, you can have one single variable mapping the campgrounds and another variable mapping the number of people that visit that campground. So you would have multivariate mapping there. When you open the attribute table, it's important to understand the data that's associated with the feature that you're being mapped. So when we talk about the level of measurement, we're talking about the information that is in each record, not the information based on the field name. And I hope that will become more clear as we begin to work with these data. So when I open an attribute table, usually the first field in ArcGIS is an FID or an object ID, and this is generated by the program. It's not anything that we have access to map or to use, and it's really critical that you don't delete that because it indexes your data. The second field usually shows the type of geometry, so this time we're looking at polygons. And then I have the different attributes. So I have a field called owner, I have a field called cov type, another field called shape area, crown cov, and density 96. So hopefully there's metadata that goes along that helps me understand what these different variables mean. But when I'm looking at this attribute table, I can see that the owner has two different owners that I can see here. One is PVT, which stands for private, and the NSF stands for National Forest System. And this data is text, and you can identify text as justifying to the left of your field. The cov type is also text. You can see it's not complete. There are some records that don't have a cover type, and I don't know what cov type means. I'd have to go back to the Mary Beth Price text and take a look at that. Shape area is a number, so it's telling me that for that polygon, it's giving me the area of that polygon, and this is a number, and I know that because it's right justified. The crown cover is the amount, the percent of coverage for that tree, or that, for that polygon, and this is right justified, so it's a number. And density is a code that is, I would hopefully have a key that tells me what that density stands for, and that's also text, left justified. So it's a really good idea to open up your attributes. I can see that there are over 2,000 polygons in this data set. And then once I know what kind of data I have, then I know which ones I can map. And what kind of mapping I can make. So I could make a quantitative map using the area. I could make a quantitative map using the cover type. I could make a categorical map based on, categorical map based on cover type and owner, probably density, and then with crown and shape I can make a quantitative map. So under the level of measurement for qualitative data, there are two types, and the first one's kind of odd. It's considered a nominal field, and it's usually a unique identifier. It's typically text, and it is used to give a name or identify something. Wow, that was well said. So a zip code, a polygon with a zip code would be nominal. I could label all the different zip code areas in the state if I wanted with a zip code, or I could use that field to name all of the states or all of the counties. There's another type of nominal data that is used commonly in social data called a FIPS code, F-I-P-S. And the FIPS code stands for the Federal Information Processing Standard. And that is a unique number that's given to each state, each county, each city in the United States so that they can be easily identified and given attribute data. So we'll look at those next term. The type of data that you would actually use to map in a qualitative data would be categorical data. And here your data records are assigned to different categories. So typically categorical data is written as text, like type of tree, where you had oak or pine. Sometimes it can be entered as a number, and that's what the FIPS code would be, a number entered as text. Sometimes it can be a code where you need a key, where 1 equals oak or 2 equals pine, or for example, when I was looking at the where is that one? When I was looking at the density. So that's a category of density, and I don't know what the key is. I need to have that. Quantitative data is the 3 levels of measurement for quantitative data is ordinal, interval, and ratio. And sometimes ordinal data will be listed under categorical data, and we can talk about that. But for mapping purposes, in order to what's the best color scheme, we're going to put them in the quantitative data group. So ordinal data means data that has been ranked. So I can have all of my different cities, and I want to rank them into high crime, medium crime, and low crime. So I might use 1, 2, and 3 to rank those cities. Or I might use A, B, C, or first, second, third, something like that, high, medium, low. When you look at the potential for earthquakes polygon in Oregon, they are high, medium, and low. That's how they're ranked. And that's based on some numeric data. And so in a way, you can think of them as being categorized, but they're categorized based on a value that has a hierarchy. So if I'm categorizing trees, I'm not saying that trees are more, oak trees are more dangerous than pine trees. I'm just ranking those or categorizing those based on just their different types. Ordinal data is ranked with some kind of value. Interval data is probably the most confusing for students. In interval data, there are only 3 types that you will ever see on a quiz or a test, or that I can think of that you would map. This data represents temperature, elevation, or pH. And it's called interval because the difference between the temperature ranges or the elevation ranges are based on this starting point of 0, and the 0 is arbitrary. A 0 temperature doesn't mean there is no temperature. And also, these have a negative number. You can have below sea level, you can have below 0, you can have below a 0 pH, I think. I'm not sure about pH, but anyway, temperature and elevations are the ones that I'm most familiar with in mapping. The most common data that we're going to map for quantitative data is ratio data. And this is where the 0 is a meaningful number. So you can have no crime in a city. You can have no population over the age of 50 in a state. So when you open ArcMap, originally the data comes in as just a single feature. So this is vegetation data, and I've opened ArcMap, and it sees each of these polygons as just a feature. It's mapping them all the same, even though I've got the 2,000 plus records. Each one is identified as a blue polygon. So when I go into ArcMap, I can choose to map one of these attributes, and for this map, I decided to map the categories of ownership. So I chose to map this showing Forest Service and private owners. And so you can see there are 2 categories in my ownership categories. But using that same attribute table, I can choose to map each quantitatively. So here I've got a Choropleth map showing the percent crown cover, 0 to 19, up to the very high crown cover, 73 to 95. And so I'm using this numeric data for the map of quantities, and I'm using this text file, categorical data, for the map of qualities. If you're making a reference map, and I don't know if I can here, I think I have this already up. There's a standard mapping tool that shows, different symbols and line weights, and how you would make contour lines, and how you would create stippled backgrounds for glaciers and things like that. So I just wanted you to have access to that. So if you're making a reference map, this would be a great handout to take a look at. So let's finish up here the quantitative maps. So remember, when you're mapping quantitative data, the level of measurement is either ratio, interval, or ordinal. So here is the map of volcanoes. I'm mapping numeric data that's showing the magnitude of each of these eruptions. So always start with your attribute table. So you want to be able to identify what is the level of measurement in these attributes. So here is data that has the FID. Again, that's just generated in ArcGIS. It tells me the geometry, which each of these are a polygon. It's the nominal data here is the city. It's in this state. That's also nominal. It's in this region, so these would be categories, because I can see that I have the city of Pig, Boise, Olympia, and Portland are all in the same category. Here's air temperature. This is nominal. This is a number, but it's interval. Crime rate is entered as text, but it's a rate, so it's a ranking, so that's ordinal. Here's population. Again, right justified, so this is ratio data, and average age is right justified, so that is ratio data as well. So I can make a quantitative map based on average age, population, crime rate, or temperature. So when you want to show quantities, you want to be able to show that magnitude, and you can do that by changing the size of the feature, by changing the texture pattern, and that's a nice thing to work with if you're working with black and white or grayscale maps, or changing the colors from light to dark. And remember, we talked a lot about Choropleth Maps that used that mapping strategy. So when you're mapping quantitative maps, you really want to think about that color intensity that's relating to the value. And you have to think about how many classes of data you want to be able to show. And so here is a Choropleth map showing divorce rate. And so the higher rate of divorce is in the dark teal and going into the lighter colors, which makes this really easy to visualize. In ArcMap, there are two common classification methods. Jenks natural breaks is the default, and Jenks natural breaks takes care of gaps in your data. It looks for uneven distribution. So if you look at the histogram of this data, and I'm not sure what I was looking at here, but you can see that each of these spikes shows the height of the data value. And so we've got a wide range here, a little narrower range here, and then these three look fairly similar. So it's going to take care of not over smoothing your data. If I had this broken into even rankings, many of these would all be grouped into one color, and you really wouldn't see a lot of the differences in your data. The problem with Jenks is that people sometimes look at your data classes and say, oh, well, you're trying to skew the data, they're not even. And so equal interval is a data classification method that people are really used to looking at, but it's not always the best choice. So with equal interval, let's say you have data that ranges from 500 people to 1,500 people, and you want to show that into 4 different classes. So you take the difference, so there's 1,000 people to divide up into 4 classes, so your data would break from 500 to 250, or 500 to 750, 750 to 1,000, and on up. So it looks fair, it looks comparable, and it's easy to understand, but when you go through the lab, you will see how equal interval really doesn't always show you the best distribution of your data. The final topic with quantitative maps is the idea of normalizing your data. So when you're trying to compare, say, the population of California murder rates with the population of North Dakota murder rates, or murders, it's difficult to do because the population in California is so high. And so sometimes you may want to know just how many murders are there, but you may also want to know what is the percent. So using normalization is a way to kind of make fair comparisons. So when I look at this attribute table that shows the population of these two cities, so here are the murders in Derryville. There's 500 murders in Derryville, and the population is 600,000. In Midsummer, which is a European British town, there are 100 murders in whatever year this was, but the population is only 5,000. So I'm looking at this and I'm thinking, wow, I never want to live in Derryville because there were 500 murders. But when I look at this data normalized, it's 2% of the population is murdered in Midsummer and only 0.8% of the population is murdered in Derryville. So looking at normalization can really help make better comparisons. There's a couple ways to normalize data. You can normalize by the density, so how many people per population. So if I want to know how many people attend one campground as another, I might want to look at the area of the campground and think, well, that campground has a lot of people, but there's a lot of area, so it's not very crowded. You could look at density of trees per acre. So it's the number of the value that you're looking at by the unit area. Percentage is another way to look at normalizing. So you can look at the number of children under the age of 10 as a percent of the whole population, or the number of divorced people as a percent of the whole population. You cannot normalize data that's already been normalized or averaged, or that's shown as a percent or a rate, because it's already been adjusted in some way. So for example, if you had the mean age, you couldn't normalize mean age.